Hi, I'm Dr. Allan now and welcome to the course Networking 1. Today is a beautiful day to learn, so let's go ahead and take a look at the introduction to network. Computer networks is a very interesting topic, primarily because it affects the way we live, the way we learn things, like this one, we are online, the way we play, and the way we transact a lot of things in our daily lives, from buying in Lazada, from sending messages to your friends, and communicating via um, messengers, other forms of communication applications, right? So let's have a couple of definitions. Data communications refers to the exchange of data between two or more devices via some form of a transmission media. So if you try to dissect the definition, it's an exchange of data between two. So there should be at least two parties involved or more devices. Take note, it did not use the word computer, but it used the word devices, meaning it's not only computer, but it could also be cell phones, small devices like cell phones, routers, or even your IoT devices such as Arduino or Raspberry Pi. And it has to travel in some form of transmission media, which it could be wired form or like cables or wireless. Like when I talk right now, it travels across airwaves. So you could use radio waves, microwaves for that matter. Next is you have computer networks. So, a collection of computers linked together using transmission media for the purpose of communication and sharing of resources. So basically, a computer networks is a subset of data communications which focuses mainly on communication of computers, the interconnection and communication of computers. On the other hand, when we talk about data communications, its main focus is on the signals, on how these signals travel across transmission media, such that noises will be eliminated, corrections can be made when some alteration happens during transmission. So computer networks is a subset of data communications. Take note at the two words that were highlighted here. You have communications and resource sharing. So basically, if you connect two computers with a cable, maybe you would like them to play. You would like to play together, so you could actually communicate. You could send messages, etc., and data back and forth. But in addition to that, and more importantly, it's about sharing of resources. So if you have two computers connected together and then you put up one printer in one computer, then you should be able to share that particular resource. You could share your drive. You could share the files inside the drive. And you could view the photos, images from other computers or to other devices that are connected to that particular network. So there are a lot of things that you can do when you connect two or more computers together. So, what can be shared? A lot of resources can be shared from hard disk, your files, the pictures inside it, your videos, the applications that you have. You don't have to install these applications on every computer. It's like when you have an enrollment system, you don't have to share that enrollment system in all of those devices, but it only stays in one particular uh, server and it's accessible anywhere. Could also share hardwares, your printer. Sometimes you have a network printer which can be shared across the entire network. And all the resources, basically. You could also share the CPU power. In fact, you could gather all the power of the CPU and come up with one bigger computer, which is somehow called a supercomputer, such that you could process more complicated um, jobs. We call that jobs. Like, for example, rendering a video that requires a lot of power from the graphics and from the CPU. Okay? So, but again, it's not just about sharing, it's about accountability, it's about security. So, when you share something, make sure you know whom you are sharing with because it could be, prone to abuse, hacking, and a lot of things. So you should also be able to secure whatever you share. That's where this course comes in. We have to protect the resource that you have. For a communication to take place, it needs at least two persons, two people that communicate with each other. One is the listener, the other one is the one talking. So if you look at me right now, I'm recording this session alone and nobody is answering to me. So basically, I'm doing a monologue. So I'm not communicating per se because I don't have anyone with me talking to me right now. So according to this, the elements of communication, you must have at least four components. Number one, you must have a sender, someone who talks. You must have a receiver, someone who listens. And you must have a message that is communicated over some form of a channel. So the message could be, yeah, this one I'm talking. It's a message in a form of English. It's a spoken message. And it travels across the airwave. So that's my channel. So now if I'm going to use a string. I don't know if that really works. You have cans on both sides, in can, and then you talk. Then that could be my channel. So when we talk about computer network as a communication, the channel could not be the airwave alone, but it could also be wires, fiber optic cables, twisted pair cables, or infrared communication, the infrared channel, right? When we have two people communicating, it's a little less complicated. However, if you add more people in the conversation, it becomes more and more complicated. Why? Because you will have a lot of people talking and some people are simultaneously talking and then eventually you will not be hearing anything or nobody is understanding each other and somehow there will be miscommunication and you will have quarrels or whatever fist fights, I don't know, but again it happens. So that's why we added a fifth item here, which is a protocol. So simply put, a protocol is a set of rules, a, a guideline for us to follow when we communicate. So number one, what could probably a protocol when you are talking in a class or talking in a group, you have a group discussion. Number one, you must have only one speaker at one time. Otherwise, it becomes a market and it's very difficult to understand each other. So that's a simple protocol. So when one is talking, the rest should be listening. Okay? Number two, for us to understand each other, we should agree on a form of language. I talk in English, so I understand all of you understand. I expect all of you to understand English, and then we agree to talk in that English manner. Then there is communication. It could also be a form of a speed. The way I talk, sometimes I talk very fast and nobody really understands me. So I try to lower down the speed and try to modulate my voice a little, and then you could have better transmission of I should say better transmission of signal. meaning my voice is audible and clearer to everyone, right? So because if I have, for example, a noisy environment, then a lot of those voices, a lot of those messages that I'm communicating to you may not be able to reach your ears and be able to comprehend to what I am saying, because simply there are so many people talking and you have dogs barking, and all of those affects our communication. Okay? So again, for elements of communication, we have a sender who can also be a receiver after some time. You just change position. You have a message to be communicated. You have a channel, and you have this set of rules that governs the communication. A network protocol is an established set of rules that determine how data is transmitted between different devices in the same network. In short, it's a set of rules that governs data communication. So we follow these rules. Everyone who is involved in the communication process should understand the rules. Otherwise, communication will not take place. So there are so many protocols available out there, and let me just give one example at this point. You have HTTP, Hypertext Transfer Protocol. When you open your browsers and you open your Norma.edu or Facebook, then you are actually using Hypertext Transfer Protocol to be able to get the websites, the web pages from the server and view it to your browser. So similarly, when you send a file, when you download the file, you are actually using file transfer protocol. It's a rules that determine how your big movie, 1 2 gigabyte movie can be downloaded to your flash drive, and so that you could view it anytime when your downloading is done. Let's take a look closer to the definition of cut. Let's take a look closer to the elements of a data communication. We have already described that there are 5 components in it. So you must have a sender, you must have a receiver, and you must have a transmission media across or between the two devices. And it has to be governed by some kind of a protocol, in which case we said it's like a language that we should follow. And whatever that language is, it has to be communicated the way it was designed to be communicated. You have the message. It could be in a form of, right now, probably you could uh, see those as videos, photos, or simple text or numbers, or it could be a binary file or an application, which could be transmitted over generally two kinds of transmission media, the wired and the wireless. Let's take a look at those components one by one. So sender and receiver is a device or a computer that generates and sends that message. So not all devices have the capability to send and receive. In communications, we term them as transmitter and receiver. So if you have the capability to transmit and at the same time you have the capability to receive, that is called a transceiver. Transceiver. So, but in most cases, if a device is capable of sending, it is also capable of receiving. So a receiver is the device or a computer that receives the message, and the location of the receiver computer generally affects the type of network that we have. If you have a longer distance, it might require more devices in between and more protocol in between, such that this signal could be able to travel in a farther distance. So it could be you have your own room and you have two computers there, and then you connected them together. then the devices that you need might only be a switch or a simple wire, a crossover wire. But if you are going to stretch it out, that will span one building or probably one campus to another campus or one city to another city, then that will be a bigger, more complicated kind of network, which requires more devices, more protocols, more software. Okay? So in this example, you have a laptop, a cell phone. You could have also this Arduino device here, which could send the signals coming from sensors. It could also receive signals coming from other Arduino devices, or simply you see it every day. Probably you're not aware you have your routers that are communicating with each other to be able to transmit your data from one point to another. Next is a message. Um, when we do the programming, probably of that subject, you know that there are different data types like text, numbers, images, video, audio. No? These are the kind of messages that could be transmitted from one device to another. However, just imagine if I have here a phone and I take a picture, a selfie of mine and send it to someone else, then how could this particular picture or photo of me be able to travel across the air, across the fiber optic cables? Can you imagine that? How could that crawl? If I am going to transfer the contents of my cell phone to my computer, then I should be using some kind of a connector like this. So you just imagine how could that particular image or message be able to traverse this particular wire. So basically, the messages that we have, it has to be converted eventually to binary numbers 1010 and its physical electrical equivalent of voltage 0 volts and 5 volts or 3.3, then it should be able to traverse or it should be able to pass through a cable because it's electricity. You have also to take note that a message is just like a simple letter that you have. So when you write something to your friend, if you ever have tried that before, then you must put in the mailbox, I'm sorry, you have to put in the envelope the address of the recipient. You have to put there, the protocol is you have to put the from on the upper left corner and the to in the middle part of the message. Then you have to write the name of the person, you have to write the address that is comprised of a block number, street number, at municipality, including zip code, and a lot of things. So that is the protocol when you send a message. Okay? Next, we take a look at the medium. It is a channel or physical path through which the message is carried from sender to receiver. So generally, there are two classifications or categories. We have the wired and the wireless. The wired is twisted pair. You also have the coaxial cable and fiber optic. Okay? When we talk about wireless, you have microwave, you have radio waves, you have laser, you have infrared when you use your remote control and control the TV, then that is a laser. That's a form of a wireless communication. And when you use your Bluetooth to be able to transmit files between two cell phones, it's also a wireless. When you applied for a cable, no, that's actually cable. It's called a, I don't know what's that, it was called cable before. Let's say signal, sky cable. It's not a cable kasi, so I was a little bit confused on that term. So you are going to use microwave to be able to receive signal from the satellite. That's also a form of a wireless. And then finally, we have the protocols. Protocols, again, is a set of rules that governs data communication. So these are just rules. So looking at this graph, you could see that there are 7 layers here, from physical, data link, network, transport, session, presentation, and application. Application, I'm sorry. Remember, I told you that a picture view, when you transmit it over a network, it has to be converted to its eventually electrical form. Okay? And these layers represents the transformation that happens from one layer to another. So from the picture down to it becoming as a signal that is capable of being transmitted over the wire. And across those layers, you will be using a lot of protocols. Example, HTTP, FTP, TCP, anything that has P in the end. Transmission Control Protocol, Internet Protocol, um, and many more. So as we go on with our course, you will be encountering these kinds of protocols, and you will be learning a lot of them, so that our message should be able to navigate the complex structure of a computer. And finally, let me show you the 7 segment of data communication. It's a diagram that shows us how two devices are interconnected with each other. It is comprised of DTE and DCE. So a DTE is a data terminating equipment. DCE, on the other hand, is data communication equipment. So basically, you could take a look at that you could take a look at it, that the communication starts with the DTE and ends with the DTE because it terminates. In between, you have DCE, which communicates. For example, my phone here, this should be able to terminate the message. I could hear the voice, I could see the picture, I could read the message, or whatever it is. I could watch the video, the message that was sent to me. Okay? So it terminates. So if I use a speaker, the sound is terminated in the speaker. The message, the voice, the music, it's terminated in a speaker. If it's in a monitor, the message is terminated in a monitor. So, but in between that, there is another device that is embedded in here, which is probably a modem, a modulator, demodulator, which the function is to convert those messages into a format that should be able to travel, that it should be able to travel across that particular transmission channel. So normally, it's a modem. A modem is a modulator, demodulator. So from one point, it modulates, sends a signal, and then when it is received at the other end, it is demodulated. In short, from digital data converted to analog, and then it becomes digital data again. Then the message is terminated to the DTE equipment. Okay, so an example here, you have a computer, and then you have a modem, and then eventually you have a telephone line. That data already should be converted into analog because it's a telephone line. And then you have the modem again to convert it back. And you have a terminating equipment as the personal computer. So that basically summarizes the two people communicating with each other. And in between them, there are some kind of devices that facilitates the transmission of data from one point to another. Right? So until then, cut. Right? So I'll see you again on next videos. network. And finally, let me show you the seventh segment of data communication. It's a diagram that shows us how two devices are interconnected with each other. It is comprised of DTE and DCE. So a DTE is a data terminating equipment. DCE, on the other hand, is data communication equipment. So basically, you could take a look at that you could take a look at it that the communication starts with the DTE and ends with the DTE because it terminates. In between, you have DCE, which communicates. For example, my phone here, this should be able to terminate the message. I could hear the voice, I could see the picture, I could read the message, or whatever it is. I could watch the video, the message that was sent to me. Okay? So it terminates. So if I use a speaker, the sound is terminated in the speaker. The message, the voice, the music, it's terminated in a speaker. If it's in a monitor, the message is terminated in a monitor. So, but in between that, there is another device that is embedded in here, which is probably a modem, a modulator, demodulator, which the function is to convert those messages into a format that should be able to travel, that it should be able to travel across that particular transmission channel. So normally, it's a modem. A modem is a modulator, demodulator. So from one point, it modulates, sends a signal, and then when it is received at the other end, it is demodulated. In short, from digital data converted to analog, and then it becomes digital data again. Then the message is terminated to the DTE equipment. Okay, so an example here, you have a computer, and then you have a modem, and then eventually you have a telephone line. That data already should be converted into analog because it's a telephone line. And then you have the modem again to convert it back. And you have a terminating equipment as the personal computer. So that basically summarizes the two people communicating with each other. And in between them, there are some kind of devices that facilitates the transmission of data from one point to another. Right? So until then, right? So I'll see you again on next videos.